Yeah. Do you want to make an announcement now or later? That may be after, so after we do your training, then we can do the announcement and then we'll start the lecture. All right. Okay. Hi everyone. Oh wow, that was nice while it lasted. Okay. Yeah. So I wanted to just quickly talk about the Pong tournament from last year. So the results are in. They're like this. So basically the way we did it is for the people who never timed out and never gave me infinite loops and stuff. Everyone was in the round robin, and then round robin just means everyone plays everyone. And then there were 2 games, so from the left, from the right, playing to 50 points. And then every time you won a game like that, you got a point. And Boya Zhang got 29 points. So congratulations. Are you here? Is Boya here? No? Oh, yeah. Yeah, come on. So in second place were Michael and Chris. So I should say yeah, so I have a virtual certificate for you, which I promise I will print on very nice. I will print it on very nice paper and hand it to you on Wednesday. Michael and Chris are in second place. Michael or Chris or both, are you here? Yeah, come on down. Yeah. Sorry, not very creative design over here. So Christina is taking pictures, which might end up on the internet if, of course, you agree with that happening. Yeah, so let me start the game. It's going to be Michael and Chris on the left, and then Boya is going to be on the right. And we're gonna see how it goes. Yeah. You can watch from the side. All right. And you want to take a picture with yeah, so just quickly and for the other people who got the award as well. Boya, can we do it? Does that work? Yeah, there we go. Okay, yeah, exactly. Congratulations. Yeah. Oh, yeah.
Thank you.
Yeah, thanks. Congrats, and then Paul, are you here? All right, congratulations, Paul. Oh, yeah. Andy? Jan and Jordan? Yeah, you want to come up? And then not to take away from you, please come down, but Yang and Kevin also, if you're here. Exactly. Exactly. Christina also having
Awesome. I'm Christina Hyder. I am the External Relations Officer for your program, Engineering Science. Also an EngSci grad from the class of 91. Can I get it? I remember when that game came out. I remember being in my friend's rec room and all of us just sitting there going, wow, playing Pong for hours on end. So this is like a total program every way for me. So the reason I'm here, and thank you very much for giving me a minute to make an announcement. You should have yesterday received an announcement through the EngSci Info Hub on Quarkus about the upcoming Engineering Science Education Conference. How many of you saw that? Awesome. Those of you who didn't see it, go and look. ESC, you might have heard about it in the orientation blog over the summer. It's an annual event that we have. It's totally unique, and it is only for EngSci students, specifically first and second year students. We have a fantastic roster of speakers coming in, including a retired astronaut, someone from Boston Dynamics, someone from Apple Health, et cetera, et cetera. So I urge you to go check out the website. On Friday, the 24th of January, your classes are going to be canceled. You probably already got a notice about that last term, so that you can attend the conference. The night before, we're having a special celebration because it is the 20th anniversary of this event. And so there'll be some treats. We're going to have some casual fireside chats with the speakers that you are all invited to. Most importantly, right now, I would like you to consider coming to the prep workshop. If you are ever intimidated by talking to senior professionals, if you're ever wondering how do I start a conversation with someone I don't know, but that I want to talk to because I have questions about career stuff, this workshop is for you. It's being held especially just for first and second year EngSci by some staff from iLead. It is on Thursday of this week at 9:45. I know you don't have class during that time, but you have to register. So please go to the website and register for that today if you can. And it will make your experience at the conference a lot better and more productive for you. Okay. If you have any questions, email me. My info is on the website. And over to you.
Thank you very much. Thanks, Christina. All right. Okay. All right. Thanks very much. So today, what we're going to do is, so you're starting actually writing in C, today, some of you, tomorrow for the rest. So what I want to do now is, again, go over what we have been talking about last week and then do some exercises. And at that point, you'll know basically everything that you know about C. Everything else is like details and applications. No big deal. So, okay. So here's the summary of all the rules that we had so far. So we have types. Every value has a type, right? So you have something like int star, char star, stuff like that. So unlike in Python, RHS to LHS just means take the contents of RHS and copy them to LHS. Always, always, always. This means address of. This means go the other way, right? So go to address PA and get the contents. You can move slots. So you can say PA plus I, and if PA is the address of the first slot, then PA plus I is the address I slots after PA. Right? So the reason this is important is going to show up in a second, but for now, what we know is that the usual way that you access elements of arrays, that's the same as in Python, is actually this, is actually go I slots after PA and then get me the contents at that address. Calling functions, again, in some ways simpler in C than in Python because it's always this. So it's always just the local A. So this parameter A gets the contents of B, and it's always just a copy. So actually the same as in Python, it's equivalent to saying the local A is equal to B. In Python, there's issues around like, really you're passing the address, not in C. In C, you're always copying the contents. Make sense? So, okay. So that's the rules. So this is slide 25. I want to do a few exercises that we can do right now, just with those rules, and then we'll move on. I want to give you, and I encourage you to actually try it and write it, and like take an A, call change A so that A changes, and then try to print the value of A. So this is really a task that's like also you practice for the midterm, you will later on, but I want you to just think about it from first principles and think about how you would do it. Okay, so think about it for a second. Try it, make it so that you can make it work. I'll go on Discord in the meantime. Yeah.
Plus equals minus equals.
Yes. Well, so again, in the sense that it's the same as A equals A plus B, A plus equals B equals. Right? How many people are thinking? Right? All right, so just to get people started, so what information do I need inside of change A in order to have a hope of being able to change the contents of A? Yeah. Yeah, you need the address of A. Right? If you don't know where the A slot is, there is no chance at all. So what is the someone else? So what is the type of address of A? Anyone? Yeah. Yeah, it's in star. So what that means is that this has to be a variable of type in star in order for it to work. And then the name doesn't matter. So usually just by convention, we say PA for pointer to A. That could be anything. Make sense? So all that we need to do now inside of change A is to go to address PA and change the value to something else. So maybe we want to say star PA equals to 42. Right? Okay. So now over here, we're calling the function change A. And we want to know what should we send there? Well, semantically, we know it's supposed to be the address of A. We can also say, okay, like the type of the value here, this cannot be A because this is of type int and this is of type int star. So those don't even match. And a lot of the time you think like that, okay, like it's not A, but it's something like A. Well, it has to be the address of A just so that this value, which is an address of an integer, matches the type of the parameter, which is also the address of an integer. So let's visualize the execution, and then let's go back to the slide and see how everything matches up in terms of the rules. So we have A is an int. Here we're saying change A address of A. So here I'll show the memory addresses. So this is the address. So what's going to happen is this value, which is this, is going to get copied to PA. Again, remember, int star is the type, right? So the value of PA, we're just going to take this and we're going to copy it to PA. And that's, so right now the function hasn't been called yet, but I press next. And what happens is this got copied here. And the reason is address of A was this guy. And we just made the local variable PA be equal to this. Now what we're saying is, okay, go to this address, meaning go to this slot and put 42 in there. So it's now 42. Make sense? So now over here, it's going to print 42. So we haven't seen something like that in Python, right? In Python, that was kind of impossible. So just to emphasize the point. So if I made change A, this would be like an easy-ish question, I guess, if you were to be doing output prediction. And then you say like PA equals 42. You don't have to copy it because it's not going to work. But let's say that here I say A equals 3, and then I say change A. Well, that's the best that you can do in Python with just integers. And obviously that's not going to do anything. It's just going to print 3. Right? The reason it's going to print 3 is, well, I tried to make it work. There's no star in Python or anything like that. So the best I could do is could just say, well, like this is A, this is PA. But really, I just made PA be equal to 3. And then I said, well, the local PA, now I want it to refer to 42. So here, there is no change. The reason there was a difference here is that we're sending the address of A. Actually, that's the same in Python. We are sending the address of A, but in Python, there is no way to say, go to that address and change the value at that address. So really, the big difference in C is that we can do this with addresses of integers. In Python, there's just nothing that's like that for integers. Does that make sense? So, okay, what is there in Python that's kind of like that? What is, yeah.
Say global A.
Well, that's globals as well, but like what's kind of like what they didn't see that's in Python that's very close, that's actually possible without global variables. Yeah.
Why would you want the value better?
You could, so the question was, why would we want to do this in the first place, rather than, for example, return? The answer is that if you want to change a lot of things at the same time, then it's more efficient to just send the memory address, is one reason. The other reason it has to do with manipulating arrays, which we just haven't done yet, but we will do very soon. Okay. Anyway, so an analogy. So anyone, is there an analogy to this in Python? Anyone? Yeah. Lists, exactly. Yeah. So lists do work like that in Python, right? So if we said, so change A and then like PA at 0, something like this. That does work, right? The reason this works is that the mechanism and the underlying mechanism for lists in Python is actually the same as in C, right? So what we're doing here is we're saying, take this variable, make PA refer to the same address, and then this is saying, go to the memory table, and in the memory table, change the location at 0 to 42. Does that make sense? Questions? Does this not make sense in Python? Because that's definitely going to be on the terms. Questions about this? Okay. All right. So, okay. So that's like that. So the next exercise on the slides was, well, now make it be in C and make it so that it doesn't change the value of A. So obviously there is lots of ways to not change the value of A. But what would be the way to not change the value of A in a way that looks like you might be changing it? Yeah.
Directly assign A to B.
Yeah. So just say, okay, like int A over here, and then A equals to 43 or something. So here I had to say address of A. I had to say address of A because the type had to be address of int. Here I have to say just plain A because this is an int and this is an int as well. So those have to match. And if I print A now, it's still going to be 42. So what's going on here? So here we're saying don't change A, right? And what's happening is this A, so the A from the main function is going to get copied to the local A here. Like this. So right now there is an A that's the local A inside the function don't change A. And there is the A that's the A in main. And the way the value got transferred is this was just copied from over here, right? So now you just have two variables that are A that happen to have the same value, but otherwise are not related. So when we say take 43 and copy it over here, that's what's going to happen. So right now, inside don't change A, the local variable A is equal to 43. But in main, there is a different variable A that's equal to 42. Those are completely separate. Yeah.
Have to use the address of A when we're calling a function to change it?
So the question was, do you only use address of A when calling a function? And the answer is usually yes, because usually if you're inside the main, like you already have the variable, why would you need the address unless you're sending the address somewhere? In principle, we had examples which were kind of contrived where that wasn't the case, right? So the examples that we saw last week were like something like this. And then you go like star PA equals to 50 or whatever, and that changes the value of A. But you could also do it direct, right? So where you would actually use it is if probably you're calling a function somewhere, because inside the function, you already have access to A directly anyway. Right? Okay. So you definitely need to remember just, this would change the value of A, this would not change the value of A, but hopefully kind of with some practice, we'll also start getting an intuition for what's going on there without just remembering the rules as well. So let's go back to which rules from the summary apply. So basically what we're using is this and this again and again and again, right? So what are we doing? Right, that's a different one. So we're saying when you call a function, what happens is that this just gets copied over here. So what this suggests is that the variable PA and the variable A, they have this relationship where PA happens to currently be the address of A, but they're not otherwise connected. But if you say copy 42 into the contents of PA, according to this, then what happens is they get copied. So star PA means the contents at PA. So that means this slot. And we just copy 42 over here. The other thing that you can have is something like this, where, again, you just copy the contents. So you copy whatever A is currently 42 into this local 42, and then you copy 43 into this local A. And that's one way of seeing why that doesn't make a difference. Yes. Say again? So the question is about returns. So return again. The way return. So here you're not allowed to do return because it says void. But if I had said something like int f, you know, int x and return whatever, like x minus 1. So that works the same way in the sense that it copies whatever is the value here to the left-hand side. So if I say something like int b is equal to f1, 2, 3, 122 gets copied to b. So I think you were asking about like changing a, right? So like in principle, I could say something like, let me know if that's what you're asking. So if I do this, then C becomes 43. But the reason C becomes 43 is that we just take 43 here and we copy it in here because it got returned. It's not to do with this kind of mechanism here. Does that answer your question? Yeah, so you could say something like, you know, like int C. So something like this, and then here you could say C equals 40, and this it's still the case that here C is 43, right? So the way the information would get out of the function, if you do it via return, is via this 43. This is just changing the local variable C. Make sense? Yeah.
The local variable done the function there.
So the question was, what happens to the local variables once the function exits? The answer is it's not really, so there is not a way to access them. You can try to say, oh, like I'll just guess at the address, maybe I'll get lucky. And you might get lucky if you guess the address where the local variable was stored. It doesn't get automatically wiped. But it's not, so this is what's called undefined behavior, where it might or might not be there. Yeah. Not just that, so the question was, are variables declared in the main function local? And the answer is yes. So the only special thing about the main function is that that's the function that gets run when you run the program. Otherwise, it's a function like any other function. All right. Okay, other questions? All right, so let's do one more thing. So let's say that I want to change the first element of the array to something else. So let's do that. All right. So again, this has to be inside the main function. So this is a little bit of a trick question because you can make it be literally the same. So you can say int star PA, that's exactly the same as the change A from before. And you just say star PA equals to 43. And that would do it. So over here, and I'll explain why in a second, over here, you can just say array. So that's kind of the simplest thing that you can do. Why does it work? Well, because this is the same as star PA plus 0, as per the slide. So same as PA at 0. So that's the Python example, right? And here, this just gets converted to in star automatically. Right? So that really is taking up to 10 seconds. Oh. Oh, because yeah. Okay. So what's happening here is array, meaning the address of the first slot gets sent to PA. So here PA is this, and we're making star PA, meaning PA at 0, meaning this guy, B43. Okay. So that changes array at 0. We could make something that looks a little bit like exercise 1. So you could also say something like change array address of array at 0. That's the same as line 8. So this is because there is like a bit of like the algebra here, which is that array at 0 is star array plus 0, right? And then that means that address array of 0 is address of star array, and the address of and the star just cancel each other out. Does that make sense? Questions about it? So you would probably either write it like this. People generally recognize that this is how it's supposed to work. If you want to emphasize that, well, like I have this value array at 0 and I want to change it, and I'm sending the address of this value so that the function change array changes it, you can write it like this as well, I suppose. This is just, a way to see why that makes sense. All right, questions about this? All right, so I want to switch gears for a second and talk about Visual Studio Code, because that's what half of you are going to be doing in the lab now. I'll ask you to initially work with Visual Studio Code on ECF. There is going to be instructions for installing it on your laptop. It's unfortunately not always easy to install kind of the C compiler. It is what it is. So the way to start it on ECF is just in the terminal, you write code. And you do this. So here are the steps that you need in order to actually run something in C. So what I'll do is I'll save the code in a folder. So I'm creating a folder here. We'll name it a.c or something. So .c, like .py, is the file name that's traditionally used for C files. Save it. I'll say include stdioh. And I'll do something like printf hello world. So again, unfortunately, it's like not extremely well supported software, so it's going to be a little bit different on different computers. You should be able to run it like this. So here I press the play button, and then I pick GCC. And over here, it printed my hello world. I might need to switch to the terminal tab in order to see it. What you in general want to do just to make things more robust, again, unfortunately, it's not like as easy as Paizo, which is why we start with Paizo. You want to open the folder where you saved the program. So in this case, ESC190 lecture. That's this thing. And at this point in the Explorer, you can pick the file name and you can run it like this. That's just the first time. Great. And again, might need to switch to the terminal in order to see the output. So this is from over here. If that doesn't work, and again, sometimes it doesn't, so try run start debugging. That sometimes helps. The button is supposed to be the same. It isn't always. So here, if you press the down button, it's supposed to be debug. So just to give you an idea of what's going on here. So what we're doing with the compiler, like we mentioned in the first lecture, is we're actually creating a program. So this is the C file, which I opened in VS Code in desktop ESC190 lecture. This A is the actual program that actually prints hello world. So the compiler compiled A.C, and then we ran this program. I can also run the program directly. So over here, the program, so here I can list the files. So the program is named A because the file is A.C. I can run the program like so. So that's going to work on ECF. And that prints hello world. Okay, are there questions about this? So this is the location. I opened the folder. So with file, open folder. I ran it the first time. That means that it compiled. And that is what created this program, which actually prints hello world, which I can run like this. All right. So what you're about to see in the lab is, errors and typos and stuff like that. So if, for example, I forget the semicolon here, so in this case, it actually kind of suggests that there should be a semicolon here. If I try to compile and run, it's going to give me an error. So one common issue is that you are still able to run the old program from when you compiled the correct one before, but now the file has updated. So here it does tell you that, there is a problem on line 5. So the problem is on line 5. And we can, put the semicolon here. And then if I run it again, that's going to run like this. So debugging works the same way it does in Paizo. So I can put a breakpoint somewhere here. Let's say that I change the value to 123 later. I say debug. We are over here, and here you can see that the value of A is currently 10. So if you want to know what is, for example, A plus 123, you can, it's going to compute it. This. So the debugger is a little bit clunkier than Paizo. Sounds surprising, but that's possible. But I still encourage you to try to use it, especially when you get to larger programs. It's really much more efficient to use the debugger. All right. I will see some of you in the lab right now. The others I'll see on Wednesday. See ya.